Hi everyone. In this one, we will continue where we left off and talk about some general rational functions. So what we have is we have that the limit x going to infinity plus or minus 1 over x to the r is 0. Let's look at our first general case. What happens to the limit as x goes to infinity of 1 over ax plus b? Okay, so it's a 1 over a general linear function. Now, of course, as x goes to infinity, right, the whole thing in the denominator becomes a large positive number. So this limit is also 0. And similarly, as x goes to negative infinity, this limit goes to 0. Okay, an alternate approach is to create terms like 1 over x to the r, because then we can use this goal. So one way to do that would be that you start with the 1 over linear function and then you divide both the numerator and the denominator by x. So you get limit x going to infinity 1 over x over ax plus b over x. On the denominator, we can do a little bit of simplification. It becomes ax over x plus b over x, which is then 1 over x over a plus b over x. Now, if you look at it individually, all of this is 0 and all of this is 0. So this is really 0 over a plus 0, which is 0. And that's why the limit will be 0. And this is going to be our go-to strategy, is we will say that when working with rational functions, we will divide by x to the m to create terms of the form 1 over x to the r. Why? Because we already have this result which says that if you have 1 over x to the r, then the endpoints are at 0, meaning that as x goes to infinity, positive or negative, it just goes to 0. So here's an example. Find this limit. X goes to infinity, 3x squared minus x minus 2, 5x squared plus 4x plus 1. Now, at this point, I encourage you to pause the video and try and see what this x to the m should be so that everything here becomes something like 1 over x to the r. Okay, here's the solution. The idea is to always divide by the highest power of x. In numerator or denominator. So whichever one has the highest power, you take that power. In this case, both numerator and denominator have x squared. So here I divide by x squared because that is the highest power. Now when you divide by x squared, you're dividing each term. Okay, in order to keep it balanced, in the sense that in order that you're not changing the function, you have to make sure you divide each term. So that would be written as 3x squared over x squared minus x over x squared minus 2 over x squared, 5x squared over x squared, 4x over x squared, 1 over x squared. After this step, you can do some cancellations. If we do some cancellations here, an x squared, x and an x and an x squared, that gives us limit x goes to infinity 3 minus 1 over x minus 2 over x squared divided by 5 plus 4 over x plus 1 over x squared. Now this is good news, because what we have achieved is we have rewritten most of the terms as 1 over x to some power. And for each of those, we know the limits. This just goes to 0, this goes to 0. So what we will be left with is simply 3 over 5. Which means y equals 3 over 5 is a horizontal asymptote. Okay, because recall that limits at infinity correspond to horizontal asymptotes. Okay, limits at infinity correspond to horizontal asymptotes. Let's look at one more example. So this says, find the horizontal and vertical asymptotes of the function f of x equals 2x squared plus 1 over 3x minus 1. Now I will be finding the horizontal asymptote. The vertical asymptote is a bonus question. If you are watching the video and you reach this point and you send me what the vertical asymptote of this function is as an email before our Thursday meeting, then you will get an extra point. Okay, so here we go with the solution. What does it mean to find horizontal asymptote? A horizontal asymptote, it basically corresponds to finding the limit at infinity. Now there are two limits at infinity here. Let's start with the positive one. The highest power that I see here is, so now it can be confusing here to consider that the highest power is x squared. But what you have to think of is that there is also a square rooting involved, right? So when you square root something which is like an x squared function, you'll end up with something that's like an x function. So here, the highest power really is x. So we divide by x. Limit x goes to infinity, square root of 2x squared plus 1 over x, 3x over x minus 5 over x. Now here, we have to work with these square root things a little bit. Now the reason why we divided by x was because we said x squared is similar, a square root of x squared would be pretty much be x. Now since we divided by x, we want to take this x inside the square root. So I'm going to write this as the square root of x squared, after which it becomes one single square root, which can then be split as 2x squared over x squared plus 1 over x squared. So which is why dividing by x is going to work. So this now becomes limit x goes to infinity, big square root of, these cancel out, so 2 plus 1 over x squared, these cancel out, 3 minus 5 over x. And for each of these terms, which are 1 over x to the r, we know the limits. They are 0. So we're left with square root of 2 over 3. which is going to be a horizontal asymptote. Okay, so this is a general strategy for rational functions. This is a general strategy for all rational functions and functions of form like something divided by something as a function of x. Okay, for example, like the last example we did is not really a rational function because the numerator is not a polynomial. But the idea is that if you have a fraction of things and those things have like powers of x, you should always divide by the highest power of x in order to get terms which are of the form 1 over x to the r. And when you have those can be, their limits are 0. Okay, gonna end this video here, so it's not a very long video. Next video, we are gonna generalize this particular strategy and look at some other examples of finding limits at infinity.